Have you tried using the engineering design process in your STEM classroom? What is it, and what are the different stages of it? And also, why should you be teaching with the engineering design process in elementary STEM? In this episode, I'll be answering all of your engineering design process questions so you can get started implementing it into your lessons. Welcome to the Elementary STEM Coach Podcast, a show that'll help you with lesson ideas, systems, and actionable tips to apply to your classroom. I am your host, Naomi Meredith, a former classroom teacher turned current STEM teacher and coach. With over a decade of experience teaching and a master's degree in STEM leadership, I am here to coach you throughout the year to help you gain back more time to create innovative experiences for your students. Grab your earbuds and let's get started. Before we dive into today's episode, I have a free engineering design process poster and planning guide that you can download for your classroom. You can grab it at naomimeredith.com/podcastedp, and I'll also link it in the show notes. A side note, EDP is short for Engineering Design Process Poster. I may or may not use this acronym within this episode, but just so you know what I'm talking about, that's what EDP stands for. When I first started teaching K through 5 STEM, I actually had never heard of the engineering design process. However, the more I started researching and developing my own curriculum, I quickly realized that this is a process that I definitely needed to be teaching in my STEM space, and I'm going to be sharing with you how you can easily implement this within your lessons as well. First, let's go over what the engineering design process even is and a snapshot of what it actually means. The engineering design process is the real process that engineers use to build, test, and create their designs. It's all about that iteration and testing it over and over. So when you think about it, this process is really the heart of trying lots of different ideas and failing, which is definitely something that we want to be teaching our students, and STEM is a great place for it. So naturally, the engineering design process has a perfect fit within your STEM classroom. And yes, this is applicable for kindergarten on up. In fact, there actually are Next Generation Science Standards, NGSS, that are all about the engineering design process. There is a set of these standards for K through 2 and also a set for 3 through 5. If you use the Next Generation Science Standards, not only are classroom teachers going to be using the engineering design process, but in your STEM space, you definitely have that opportunity as well. I also get a lot of questions if the engineering design process is replacing the scientific method, project-based learning, or PBL, or even design thinking. In my opinion, you are not replacing those methods. Those are all different and important methods, which we can do future episodes on as well. I even have a few people in mind that I can talk to you about some of those topics. The engineering design process is its own thing and has its own place alongside of these processes. It's definitely up to you if you want to teach with the engineering design process all year long, which I typically do, or maybe you want to mix it in with the scientific method, PBL, or even design thinking. This is definitely your call, or if you're on a planning committee or what your administration is hoping for you to do. So this is just another format and another way to teach these amazing STEM concepts to your students. Now, when you research the engineering design process, there are a lot of different stages, but they pretty much are saying the same thing. So here is how I have broken it up into 6 stages for you to teach to your students. I'm also going to be talking about how you can teach with this method and give you a sample of how I break up these stages, along with a sample lesson plan and how these stages are implemented along the way. The 6 stages that I have the engineering design process broken up, which is in that free poster for you to download, is first, ask, what is the problem? Second, imagine, What are possible solutions? Third is the planning stage. What could your solution look like? Fourth is the create stage. Bring your plan to life. This is students' most favorite part. The fifth stage is experiment and improve. Test your solution and make it better. Finally is share. Share what happened. Just like when you're thinking about the writing process or even those other methods that I just talked about, these aren't a one and done type of stage. These are things you can always go back to if something doesn't work, go back to a previous stage. I always tell my students this as well. Yes, I am teaching them in phases throughout the week, but if they're not done with this stage, they can continue in that place. And maybe they don't even get to that next stage. That's just where they're at in the process. Likewise, if a creation doesn't work, they can always go back to that planning stage, create a new one, and then go through that creation and experimenting again. So these steps are not set in stone. They're very fluid, but it also is good for students to have structure so they know where the project is going. And it's not always just create, which you can do. You are bringing more meaning into your lessons when planning with this process and also using the standards alongside it. Now that you have a basic understanding of what the engineering design process is, let's talk about a sample structure that you can use in your classroom and how you can teach each of the different stages. Currently, I teach K through 5 STEM 5 days a week, the same students for the entire week. I know in past episodes, like we talked about in episode 12, some of you teach STEM to all the kids in the school, but you only see that same group of kids once a week. You can break this up how it works best for you, so let's talk about sample structures for both. First, let's talk about if you see the kids 5 days a week in a row or something similar to that structure. On day 1, I present students with the question, the ask. Now, you can have students help develop this question with you, but I know in this special space, you are very limited for time. So I actually develop the question ahead of time based on the science standards that I want to hit. Now, if you're curious about how I actually get to the planning piece, make sure to go back and listen to episode 14, where I talk to you about how to create your year-long plan with the standards in mind. So we are in that ask stage, and I ask students the question that we're trying to solve, and then we move on to the imagine. The imagine is where we are thinking of lots of different possible solutions, and this isn't actually their formal plan. This is the part where you want to tie in lots of different resources for kids to explore. This can be in the form of videos, websites, ebooks like Epic Books, podcasts, infographics, even real books are a great resource as well. This is a time where students are exploring all of these different resources to help them gather ideas of what can work for their invention. This is also a great time to talk about the science behind the experiments, and this can even be part of the research as well. So this is where you're really boosting up that background knowledge and getting kids excited for what they're hoping to create. On day 2, this is where I might finish up some of that imagining, depending on the structure of how that's presented to kids. Sometimes it is more guided where I am sharing the information and we are writing down our ideas together. But further along in the year, especially with the older students, the imagine stage is more independent and they might have a graphic organizer where they're capturing their thoughts and accessing the resources on their own. Day 2, we're finishing up that imagining, and then we're really focusing on that plan. Plans can look a lot different in a lot of different ways. We usually think of plans how it can be a simple draw and label your plan type of thing. Doesn't at least start there. There are a lot of different ways that you can plan, which we will talk about in future episodes, so you can really build up the different planning methods when you use the engineering design process. Day 2 students are working on that plan, maybe even have a shopping list, which we talked about in episode 6, where you're managing that maker money. And then they're ready when they come in on day 3, where they get into that create and experiment and improve stage. This is where you can really step back and see how kids are problem solving and really trying to bring those plans to life. This is always their most exciting day. I always teach with the engineering design process, and I use this over and over again. And let me tell you how this definitely paid off in my classroom. We were working on a STEM survival camp challenge. I believe it was 5th grade, and we only had 3 days. I think it was something with the schedule where I only had 3 days with them. Anyway, I wanted to make sure they actually had time to create. So we did some imagining, and then I told them, okay, you can just talk about your plans. Totally fine. You can draw if you want. I'm not kidding you. Every single group decided they wanted to draw their plan, and they were very thoughtful, and they were labeling. They were drawing more than one side, and they were really involved in that planning process. This was a proud teacher moment, I must say, because I didn't even force them to plan, and they wanted to plan. Keep going. This process is a year-long thing that you will continue to work on, and you might get a little bit of whining at first, but you are the teacher. Your job is to teach them and to help them research and gather ideas. STEM isn't just the creation part. There's some stuff you have to do before that, and hopefully your invention even makes sense. So the creation part is actually, I feel like, the easiest part of your job, but really getting kids to understand why they're doing things is going to make their projects even better. So here we are, day 3, the kids are experimenting, they're improving, and then moving on to day 4, they're still creating, they're still improving, but also consider giving them ways that they can improve their designs. Instead of saying, oh, just do this, having an actual checklist that is related to the project can be very powerful. And they could be things they may or may not have to do, but that will help them think about their designs in a different way, which we'll talk about in the example lesson I have in just a little bit. And then finally, on the last day, they're doing any finishing touches, and they are sharing their work, which could be just talking to other groups about what they did. My personal favorite is to create videos and pictures within Seesaw, and also having reflection questions where they can talk about what went well, what would they try again, and what was actually challenging for them is a great way to be reflective and really think about this whole process throughout the week. Now, if you don't see kids 5 consecutive days in a row, here's how I would break up the engineering design process for you. Day 1, you can start with the question, the ask. Do a quick imagine stage where you are guiding that. It might not be as independent for the kids, but you're still providing that information for them to build some background knowledge. And then dive into the planning. That way, when kids come back the second week with you, they have a plan that they've already started. So you could even watch another video to trigger their memories, and then students can begin planning and then create. Then that final day, they come back to you, day 3, they can finish creating their designs, and then they can, of course, experiment and improve when they're creating, and then they can share their work with some of those ways that I talked about. You're going to actually want to condense things even shorter, but you definitely can still fit this process in. It just takes a little modification and careful planning on your part. Okay, so now let's talk about an example lesson, how I actually use these stages with a 3rd grade lesson in my STEM classroom. I picked 3rd grade because it's right in the middle. You can definitely flex this lesson up, or you can flex this lesson down. But I do use the engineering design process K through 5. And so I wanted you to visualize how this could work in my classroom, but also in yours as well. We started off on day 1 with the ask, how can you create an invention that will reduce the impacts of flooding? This connects to the NGSS standard that is specific to this 3rd grade unit. From there, we went into the imagine stage where I had a variety of resources for kids to explore to see how flooding is actually a problem and different ways that people have already been able to solve it and are continuing to solve the problem. Now, flooding isn't going away, but there are some inventions already out there that I wanted kids to see. So I included pictures and videos for them to explore to see what inventions are working and ways that they could maybe create something similar, but also trigger ways that they could improve those designs that are already out there. We also talked about what flooding actually is and how it can be a part of severe weather. Not always, but it often can be. And then I also provided them some links to some websites about different places in history where flooding was a huge problem and what the effects were of that. And also maybe some success stories within those pieces of history where that was really beneficial as well. This was all within our day one, and we finished up some of that imagining on day two. Day two, once that imagining piece was in place, we really focused in on their plan. Now, students are using that imagining information to really help them develop their plan and how they could create that invention that will help reduce the impact of flooding. Now, we did talk about reduce instead of stopping. They don't have to stop it completely, but how could they get it to where it's not ruining a home, you're really slowing it down? Students were thoughtfully planning their designs by drawing and labeling and also explaining how it actually works. I had like to have kids still plan on paper for this project, but then I do have them take a picture and add it to Seesaw where they can actually record their voice or even type their answers to those questions that I'm asking. Day three is when we dive into that create stage. For this project, they do get a tiny little house made of paper that they can tape onto a plastic block. And then they also get a plastic bucket that they can build their design in. When we are experimenting towards the end of the week, that's when we actually add in the water. So water isn't there on day three. This project also involves the maker menu that I talked about in episode 6. So make sure to go and check that out because that is a game changer for this lesson. Day 3 is all about having that plan, grabbing and shopping materials, and starting to create the invention in their plans. Day 4 is a little more shopping and more experimenting and improving. And I also give them a modification checklist where they can look to see how they might want to improve their designs. This one is a little bit different because they are actually testing their design with water. So not only does it include different modifications that they can use in their design, but it also includes what their guess is as to what will happen. And then there's another column as to what actually happened. You don't have to do this for all of your checklists, but when it makes sense, having a before and after type of checklist is really helpful. So kids can actually think forward as to how their invention will actually respond to the situation. On the final day, that is our real experiment. And so we add in the water. I do have the kids take a picture or video of their design, again in Seesaw, to show what it looks like before it gets wet. And then we also take a final picture as well. Students are having such a blast, not only looking at their designs, but noticing how other designs work in the class. So it's a little bit of friendly competition, but it's just so much fun to see how their inventions actually work. When we're finished and clean up with the water, there are some reflection questions, and I use the same questions all year. So students are used to that format, but they have different responses because the projects change. The 3 questions that I like students to reflect on, either through writing, typing, recording their voice, recording a video, are, I am proud of, if I were to try this challenge again, I would change, and they explain something that was challenging for them. So within 5 days, we get through all of this content, we clean up, there aren't any projects left in my room, but it's really cool how we can really zone in on the impact of floods and really go through this whole engineering design process together. As a recap for today, we talked about a whole lot, so let's just go over all of those different things. First, I explained what the engineering design process is and all of those different stages. Next, we talked about how you can teach with those different stages depending on when you see different classes. And finally, I shared with you an example lesson of how I use the engineering design process from start to finish. Over the next few episodes of the podcast, I'm actually going to be diving deeper into those different stages of the engineering design process and share with you different ways that I like to implement each stage and different resources along the way. So this can really impact your planning and make it meaningful. And so you're not also doing the same exact thing for every single lesson, but you're mixing it up and keeping kids engaged. Also, don't forget to grab your free engineering design process poster and planning guide, which will be linked in the show notes, so you can definitely dive on in and get started. You can grab that at naomimeredith.com/podcast-EDP. Thank you so much for listening to today's episode of the Elementary STEM Coach Podcast. I would love to connect with you over on Instagram at @NaomiMeredith_ or send me an email to elementarystemcoachpodcast@gmail.com. Also, make sure to check out my website, naomimeredith.com, to see all the show notes from today's episode and shop my K-5 STEM resources. Any questions you have, needs for resources, or ideas for episodes, get in touch. I'll talk to you soon.